Hello everyone and welcome back to the channel. Today we are going to break down and derive the triple angle formula for cosine, which is cosine 3a equals 4 cosine cubed a minus 3 cosine a. To start this proof, we express the angle 3a as the sum of two smaller angles, rewriting it as cosine open parenthesis a plus 2a close parenthesis. This clever step allows us to unlock the solution by applying the fundamental cosine addition identity, which states that cosine of x plus y equals cosine x cosine y minus sine x sin y. By substituting a for x and 2a for y, our expression instantly transforms into cosine a cosine 2a minus sine a sin 2a. Now to move forward, we need to address the double angles, cosine 2a and sin 2a, using their respective double angle identities. Since our final goal is to have the entire equation in terms of cosine, we choose the specific cosine double angle identity. Cosine 2a equals 2 cosine squared a minus 1. For the sine term, we use the standard sine double angle identity. Sine 2a equals 2 sin a cosine a. Substituting these two identities into our main equation gives us cosine a open parenthesis 2 cosine squared a minus 1 close parenthesis minus sine a open parenthesis 2 sine a cosine a close parenthesis. Next, we simplify this expression by distributing the terms. Multiplying cosine a through the first parenthesis gives us 2 cosine cubed a minus cosine a, and multiplying the second set of terms gives us minus 2 cosine a sine squared a. Putting it together, we have 2 cosine cubed a minus cosine a minus 2 cosine a sine squared a. Notice that we still have a sine squared, a term lagging behind, which prevents us from having a pure cosine formula. To fix this, we invoke the famous Pythagorean identity, sine squared a equals 1 minus cosine squared a, and substitute it directly into the equation. This yields 2 cosine cubed a minus 2 cosine a times 1 minus cosine squared a. Finally, we expand that last term by distributing minus 2 cosine a, which gives us minus 2 cosine a plus 2 cosine cubed a. Now let's combine all our like terms. We add the 2 cosine cubed a terms together, 2 cosine cubed a plus 2 cosine cubed a, to get 4 cosine cubed a. Then we combine the single cosine terms, minus cosine a minus 2 cosine a, which simplifies beautifully to minus 3 cosine a. And there you have it. By systematically applying these identities, we have successfully proved that cosine 3a equals 4 cosine cubed a minus 3 cosine a. It is a beautiful piece of trigonometry that connects single, double, and triple angles flawlessly. If you found this step-by-step breakdown helpful, don't forget to hit that like button, subscribe for more math tutorials, and leave a comment below on what formula we should derive next. See you in the next video.